This test is going to cover, or sorry, this video is going to cover the ratio test. The ratio test is actually one of the most important tests that we'll use beyond series. Okay, so it says students will apply the ratio test to a series using limits to infinity to determine the convergence of a series. Okay, so we've learned our geometric series tests. We've learned nth-term tests, integral tests, p-series tests. We did limit comparison tests. So this is kind of the next one. So we're almost done with all the different tests for convergence and divergence. But like I said, this is one of the most important ones. So let's kind of look at what this test says. Okay, the ratio test says if we have a ratio of non-zero terms, that just means a sub n is not zero, continuously zero. We know that the series will converge if the limit as n approaches infinity of the ratio of two consecutive terms is less than 1. Okay, so that's kind of weird. Okay, so let me get a pen. So when we talk about this right here is the ratio of two consecutive terms of the same series. Okay. Not same like insane, but same. Okay, this is usually the test that we go to if we have a mixed series. So a series that's part geometric and part p-series, or part exponential and part factorial. So this is kind of the test that we use for our mixed series. This is the go-to test for that. Okay, so if that ratio is less than 1, we're going to get convergence. If it's greater than 1, we're going to get divergence. If it's equal to 1, then our ratio test is inconclusive and we need to use another test. Okay, but if you'll notice the absolute value, so here we don't care whether our series are positive or negative, that doesn't matter because we're looking at the absolute value itself. Okay, so the first thing I want to do is get to my consecutive terms, and I'm going to do the A slowly, and then we can actually jump into them and do them a little bit faster once we get the hang of them. Okay, so if I think of 2 to the nth power, that's geometric, over n factorial, so mixed series here. So to get my consecutive term, all I'm going to do is everywhere there's an n, I'm going to put an n plus 1. So everywhere there's an n, I'm going to put an n plus 1. Okay, so that's what we mean by the consecutive term. So now the criteria or the conditions are about the limit itself. So that's what I'm going to do next. I'm going to set up my limit for this. And this is one that involves a lot of algebra. Okay, so we're going to take this one slowly. If we take our nth plus 1 term, we're going to take the absolute value. And divide it by our current term. Okay, a lot of times you're going to get a fraction over a fraction, so kind of like we did with our ratio tests. After this one, I'll kind of jump into just writing it as the product of the reciprocal. Okay, so I want to do that really quickly. So our So just the product of the reciprocal. So now what I'm going to do is I'm going to start manipulating some of my terms, and basically I'm going to manipulate my nth plus 1 term to start splitting it up and using those properties of exponents or factorials and things like that. That's going to help me start canceling some things out. Okay, so 2 to the n plus 1. Remember, we can write that as 2 to the n times 2 to the first power. Excuse me. And that's going to help us out. And then on the bottom, remember n factorial, like if we wrote 3 factorial, that was just 3 times 2 times 1. So if we think about n factorial, it starts with that term, And then our next term is n minus 1, and then n minus 1, and so forth and so on. Okay, so now if we think about n plus 1, that leaves us with our first term times our next term times the one before that. But really, that's just times n factorial, because that n, that's like writing this as 3 times 2 factorial. Same thing. But the reason I want to split that up is because that's going to help me to eliminate this term right here. Okay, so that's going to kind of be a habit when we're dealing with factorials, is to break up the factorials into terms so we can eliminate another factorial. I know that seems crazy, but it's going to work out. And then we have n factorial over 2 to the n. Okay, and by breaking it up like this, it allows us to cancel out that n factorial. It even allows us to calculate that 2 to the nth power. So really, if we think about everything that's left, all we have left is, in fact, the absolute value of 2 over n plus 1. And that gives us a limit that we can truly evaluate. So if we think about as n approaches infinity, for this particular one, that means my denominators are getting really, really, really big, which means this is going to be equal to 0. And going back to the top, if our limit was less than 0, which 0 is, less than 1, which 0 is less than 1, we can say that this converges. So this, I would say, is less than 1. Okay, and because it's less than 1, this is my, this is the work that shows my conditions. So now I can say the series. I want to establish that we're dealing with a series. I want to answer the question, so this one converges by the ratio test. Okay, and there we go. Okay, so let's do one more example. So again, what I'm going to do is everywhere there's an n, I'm going to put an n plus 1. This one's going to get pretty tricky. So we're going to do that. Okay, so now I'm ready to start my limit. So the limit, as n approaches infinity, of the absolute value. And I'm starting with my n plus 1 term. So I'm going to start splitting it up. So this n plus 1 squared, okay, you can't really split that up, but I can split up that 3 to the n plus 1. Think about this as n plus 2 instead. Okay, so really I can split up to 3 to the nth times 3 squared. All over, and again, 2 to the nth times 2 to the first. Okay, so that's my nth plus 1 term, and I want to multiply it by my, or divide it by my nth term, which is really just multiplication of the reciprocal. So I'm going to do that right now. Let's go 3 to the nth times 3 to the first. Okay. And now my next step is to start eliminating. Hopefully within this process I've gotten some things that I can eliminate. So for instance, I can eliminate the 2 to the nth power. That's nice. I can eliminate the 3 to the nth power, which is also nice. And really after that, that's all I can eliminate. So I want to bring everything else down. So on top I have 3 squared, which gives us 9 times n plus 1. Let me rewrite that. I have 9 times n plus 1 squared over, and on the bottom I have 2 times n squared. Okay. If we think about it, this n squared and this n plus 1 squared, those are going to have the same exponent, because if we expand the n plus 1 squared, so if we expand this piece right here, we're going to wind up getting n squared. So really they're growing at the same rate, and because we're dealing with a limit to infinity, we deal with our leading coefficient. So really it's going to be 9/2, which is greater than 1. Because it's greater than 1, we know that this series is going to diverge. So I would say the series, establish that we're dealing with a series, answer the question by the ratio test. And there we go. And remember, your limit and your work that we did above is the conditions. You've established the conditions at which we can say convergence and divergence. So go ahead and try that last one on the paper C, and then come in tomorrow with an answer, and we'll see how we did.